Total station differential leveling. Traditionally, typing, barometric leveling, trigonometric leveling, and differential leveling are used to determine the difference in elevation between points. But because of the more advanced technology we have, these traditional methods are now replaced with modern surveying, in which most of the instruments used are electronic distance measurements, EDM devices, such as total stations, to measure vertical and horizontal distances. This instrument is used in the method known as total station differential leveling, also called trigonometric heighting. Differential leveling is the process of finding the difference in elevation between two or more points based on the measurement of vertical distances from a horizontal line. On the other hand, total station differential leveling is a variant of conventional differential leveling, which is often used when traversing to calculate the heights of control points. The height of the instrument and the height of the target are the only further observations required. Basic principle of total station differential leveling. To determine the elevation difference between points P and Q, a total station is set up at point P and the rod standing at point Q. The height of the instrument has been measured using a small tape. By trigonometry, the horizontal distance d, or the slope distance t between the points, are needed, and the vertical angle from one station to the other has to be measured. As indicated in the figure, either the vertical angle alpha or its complement to 90 degrees, the zenith distance z is equal to 90 degrees minus alpha is measured. The basic equation for trigonometric heights is shown in figure 1, where z is the zenith distance measured at P, h is the height of the horizontal axis of the theodolite above the ground point, which is equal to the instrument height, and I is the target height of the target Q above the ground point. This equation is only valid for short distances. Earth curvature and bending of the sighting ray due to refraction have to be considered for longer distances. The correction of curvature and refraction is represented by HCR is equal to CR times D over 1000, where CR is equal to 0.0675 for distance D in meters and D is equal to T sine Z. Errors in total station differential leveling. Dealing with total station differential leveling involves systematic and random errors. The sources of error include digital reading accuracy, vertical automatic compensator error, distance reading accuracy, the slope distance, setup accuracy over the measuring point and target point centering accuracy, and the accuracy of height of instrument and target. To minimize the errors, the following are listed below for an EDM total station to have. Advantages and disadvantages of total station differential leveling. Advantages. Number 1. Large elevation difference can be measured over short distances. Number 2. Elevation differences of remote points can be measured in one step. Number 3. Elevation differences of obstructed points can be measured. Disadvantages. Number 1. Less accurate than spirit leveling. Number 2. Distance, either slope or horizontal, between two points must be always known. Elevation of underground mines. Did you know that the world's deepest mine is simply named Dump Nang Gold Mine? It is located in the Gauteng province of South Africa. It was the last underground operation by Anglo Gold Ashanti in South Africa, which extends to a depth of almost 2.5 miles below the Earth's surface. The method to be used for underground mining depends on the concentration or strength of the surrounding rock and the various risks involved. Mining is the process of extracting minerals and metals from the earth. These materials occur in their pure form called ores, which are concentrated in certain regions in the form of deposits. These deposits usually occur beneath the earth like a rock layer, forests, or oceans, which makes accessing them difficult. Depending on how these ores are extracted, mining methods can be categorized as surface or underground types. In surface mining, the rock barrier on top of the deposit is removed to access the ore. However, sometimes such deposits occur too far below to access them from the surface. In such cases, they are extracted by leaving the overlying rock intact and accessing the deposit directly from below. This method is called underground mining. Special tapes of lengths up to 1,000 meters stored on large reels. These are available for the transfer of heights from the surface to the underground workings. Principle of height transfer. The tape is slowly lowered to the required level and the weight is suspended at its end. The weight should preferably be equal to the tension used during the standardization of the tape, usually 10 to 20 kilograms. A benchmark tied to the existing leveling network on the surface is established near the collar of the shaft. Underground benchmarks of the same type as those on the surface are cemented in the walls of the oriented levels near the shaft opening. Two survey crews with spirit levels take simultaneous readings on the tape at the surface and at the end of the level. Usually, a set of 10 readings is taken, changing the position of the tape, lowering or raising by a few centimeters between the readings. The tapes are usually marked every 10 centimeters. Therefore, additional short scales with 1 mm divisions are clamped to the tape at the reading heights. Measuring the depth of shafts is determined by measuring the hoisting rope. On this same concept, a weighted wire is lowered to the shaft and measured as it descends. A tape is stretched parallel to the wire or rope at the top and its endpoints marked on the wire. The wire has lowered the length of the tape and again marked, and so on, till the first mark reaches the lowest part of the shaft to be measured. Although it is true that a hoisting rope or wire is very elastic and stretches to a measurable extent, this method is good for shallow shafts where the elasticity of the wire would give a negligible amount of stretch. In measuring incline depth of shafts, due to the slope on the shaft, the measurements are calculated step by step as illustrated in the figure. By adding each individual measurement, the total depth of the shaft is calculated. In measuring vertical depth of shafts, it uses instruments such as steel tape, shaft tape, special wire tape. These tapes are only a few examples of instruments used in determining the elevation. Number 1. Steel tape. For shallow mines, the depth of the shafts can be measured by steel tape directly. In using steel tape, in measuring the elevation, it requires for a platform to be placed into the shaft as an elevator that can be utilized to measure the vertical distances. Through obtaining the sum of the piecewise measurements, the total depth can be calculated. Number 2. Shaft tape. In using the method of shaft tape, two stations are being employed. One is at the top of the shaft and another is on the bottom of the shaft. Both stations will have separate readings, and these readings are then added to calculate the total depth of the shaft. Number 3. Special wire tape. Measuring shaft depth with special wire tape is the same as measuring the shaft depth with shaft tape. The only difference is that in this procedure, a scaled measuring table is placed on the top of the shaft near to the shaft tape. Underground leveling. Transfer of the heights to the mine through a vertical shaft may also be made with electro-optical distance measuring (EDM) instruments if the visibility conditions are favorable. There are two ways to perform this type of leveling. Number 1. EDM instruments should be clamped in a vertical position above the shaft opening. Being clever is needed from the surveyor and the cooperation of the mining workshop to make the necessary adapters and brackets to fasten the instrument in this manner. The heights of the center of the instrument and of the reflector must be carefully determined by means of spirit leveling from benchmarks. Number 2. Use the EDM equipment in its upright position near the shaft opening using a good quality mirror first surface coating to direct the electromagnetic signal down the shaft. Laser instruments with visible radiation should be used to facilitate the search for the reflector at the bottom of the shaft and to find a reference light spot on the mirror so that it can be referenced to the benchmark by spirit leveling. There are 3 orders for leveling the network in the mine. Height measurement in the 3rd order network is carried by trigonometric leveling simultaneously with the transverse measurements in the horizontal control surveys. Trigonometric leveling is also frequently used in 2nd and 1st order networks when running the leveling traverses through races and other inclined openings. Because of the comparatively short distances and usually quite stable atmospheric conditions, the accuracy of the trigonometric leveling in the mine is competitive with the spirit leveling if proper precautions are made in the measurements of the height of the instruments and the target. In view of such completeness of the surveying solutions for mining professionals that are now available, one could be inclined to rest in one's laurels. What else is left to wish for when so many state-of-the-art solutions are making surveying relatively easy? Nevertheless, broader technological developments deserve a mention here as being said to make mining even more productive.